Hi, this is part 1 of a 2-part video where I will go over the 9 main components to create your own complicated circuits. This video will go over the first 4, breadboards, LEDs, resistors, and diodes. The second video will cover buttons, switches, transistors, capacitors, and integrated circuits. The second video objectively covers more important topics, but it is always better to start at the basics. For this tutorial, you will need one breadboard, LEDs, resistors, diodes, some power supply that will provide 3 volts, and wires. I have flat breadboard wires and regular jumper wires with me. Without any further ado, let's get started. We are going to start with the breadboard, the area where you will place all of your components. Breadboards are plastic slabs with holes in them. There are 2 pairs of positive and negative stripes along the sides. The negative rail can also be called ground. These stripes are connected together with long metal clips. This means that if I put 2 wires in the same rail, then they will be connected. The large middle section is kind of the same deal. These rows of 5 are also connected by metal clips. This means that if I connect 2 wires in the same row, then electricity can pass from one end to the other. This is a little diagram to explain my point. The black lines are inner clips, and the 2 things connected to the same clip is just like putting them together. You want to place your power supply in the 2 long rails. I have a DC power supply, but 2 AA batteries and a holder like this can work just as well. You want to connect the black wire to the blue or black rail depending on your breadboard, and the red wire to the red rail. I recommend not having your power supply connected to your breadboard while working on it, as you could get shocked. I will leave my power supply connected as I can just turn it off with a button. Now, before you start placing wires, you need to learn about short circuits. A short circuit is when you have a direct path from the positive rail to the negative rail, with no other components in between. Do not do what I am about to do. Whenever you see a stop sign in the top left corner of this video, do not follow my steps. If I place a wire from the positive to negative directly like this, your power source will start to overheat and has a chance of exploding. To prevent this, we will use a resistor. A resistor lowers the amperage and therefore the voltage of your circuit. Ohm's law states that voltage is equal to current times resistance. Like I said before, a short circuit is a direct path from positive to negative without any other components in between. Placing a resistor instead of a wire makes the circuit safer. Resistors are omnidirectional, so they can be placed in any orientation and still work. This does not apply to most other electronics. There are many different kinds of resistors. You can usually see the resistance of a set of resistors on the paper band at the top. You will most likely see a number followed by R, K, or M. The base units of resistors are ohms, marked by an R. There are kiloohms, which are 1000 ohms with a marker of K. Finally, the biggest resistor you will most likely see is 1 megaohm, 1 million ohms, and marked with an M. If you would like to try the very simple circuit I have here, use a resistor of at least 10 kiloohms. Any less than that could still make your power source overheat. If you don't have these paper strips, you can tell the resistance of any resistor using the bands. There are 2 types of resistors, 4-band and 5-band. This refers to the colored bands on the resistor itself. I usually use 4-band resistors. I have this chart here to help with decoding it. If you see a gold or silver band at the very end, you want to start from the other side. I have this 10 kiloohm resistor, so we will start with decoding that. The first band is brown, which is 1 on the chart. Next is black, which is 0. So far we have 1, 0, or 10. Finally, the third band is orange. The third band on a 4-band resistor is the multiplier. It uses its own separate column. Orange on the multiplier chart is times 1000. So you do 10 from before times 1000, which equals 10,000. 10,000 ohms is 10 kiloohms. The fourth band, which is most likely gold or silver, does not matter in this case. A 5-band resistor is very similar. In this case, I have a resistor with red, red, black, black. Red, red, and black is 2, 2, and 0. The last black is times 1, so it's a total of 220 ohms. We'll quickly go over diodes. There isn't much to do with them, but they are very important. Let's say you have a circuit that looks like this. If you look closely, you will see that there are 2 paths to ground, one that goes directly to ground, and one that goes through a resistor first. One thing you need to know is that electricity will always take the path of least resistance to ground. This path has 0 resistance, and this path has 10 kiloohms or more of resistance. While the path of 10 kiloohms or more of resistance is safer, the electricity will go straight to this path and create a short circuit. To prevent this, we can replace the shorter path with a diode. A diode is like a one-way gate for electricity. As you can see here, the black strip is on the right side of the diode. This means that it will let the electricity go right and stop it from going left. We can replace this wire here with a diode. Now the electricity can't go through the diode and short circuit. This isn't the greatest example though, as you could just remove the diode altogether and still be perfectly fine. There are, however, many more important uses for them. I saved the most fun for last, LEDs. LED stands for light emitting diode. It has diode in the name, which means it works on the same principles, restricting the flow of electricity in one direction. Unlike how diodes have a black band to indicate directions, LEDs have one long leg and one short leg. The long leg is called the anode and connects to positive. The short leg is called the cathode and connects to negative. These long and short legs apply to more than just LEDs. The same thing goes for most other electronics with long and short legs, like capacitors, which you'll see in part 2. If I were to just put my LED with the positive leg on the positive rail, and the negative leg in the negative rail like so, then my LED would burn out. Most LEDs need a resistor when powering them with 3 volts. The most common resistor used is the 220 ohm resistor, red red brown or red red black black. Place the long leg of the LED into positive and the other leg into any other center rail. Take your 220 ohm resistor and place one leg into the same rail as the cathode of your LED and the other leg into negative. Now you can see that once I give it power, you have a shining LED. One exception to the rule of resistors is green LEDs. This does not apply to everyone, so make sure you check your LEDs to see their voltage rating. If it is rated to take 3 or more volts, then you do not need a resistor. Again, be very careful and check the voltage rating on your LEDs. Having my green LEDs not need resistors is very useful for testing, as not needing a resistor means that there are less components that could go wrong. That's all there is to learn in this tutorial. I've set up 4 challenges which you should see on screen now. Read the text to understand the goal, and copy the breadboard in that video. Try and complete the goal using the knowledge you have gained in this tutorial. If you do not know how to complete one, watch the corresponding section back on the video. All the answers are here. If you have any questions, feel free to comment them and I will respond if I have the answer. Take care.